This is going to be an attempt at explaining how the RGB LEDs work that are in your lightsaber blade from Galaxy's Edge, and with an eye towards why it behaves, why colors aren't quite right sometimes, and possibly how to repair it. So let's dig in. First, I want to talk about what an LED is, a light emitting diode. In schematics for electronic circuits, the symbol for a diode is this triangle with a vertical line like that. That's just for a regular diode. It lets electricity only pass in one direction, from the triangle to the flat line in that direction. You could think the triangle is pointing like an arrow in the direction that electricity will flow through a diode. It can't go the opposite way. This symbol has a couple arrows pointing up from it, letting you know that something is being emitted from this diode. It's light. This is a symbol for a light emitting diode. The side where the positive side, where electricity enters the diode, that's called the anode. Where it comes out, that's called the cathode. They're marked usually as A and K. I know cathode is spelt with a C, but the great gods of electronics decided we'll just stick a K there instead. So let's show how that works. Here we have some LEDs. Let's just focus on this one, this set of three for now. So I have electricity coming in from the left-hand side here. You see where that positive sign is, and it's going into each of these LEDs through this little switch box, so I can turn or disconnect each one, and then through a resistor here on the right to ground. The resistor is there to control how much electricity goes through the LEDs. If those weren't there and I hook this up, these LEDs would immediately break and no longer work. So I can turn these on and off. These switches are really stiff, so pardon me, but you can see, cut the power to blue. Now I have red and green. Wow. And you think, well, that's pretty obvious. This makeup, though, of a red, green, and blue LED is what you find inside of an RGB LED, which is, it looks like one LED. It actually has three LEDs inside of it, a red one, a green one, and a blue one. And this moment here, only the green one is turned on. If I turn the red one on, red and green make yellow, red, green, and blue make white, and so on and so forth. Your lightsaber blade has a whole bunch of these RGB LEDs. A peek at what is inside of those. There are two types worth mentioning here: common anode and common cathode. It just means that each LED has 4 pins in it, one pin for each color, red, green, and blue, and then the fourth pin will be connected to either all of the anodes, common anode, or all of the cathodes, common cathode. So the RGB LEDs in the Savvy's, in the Galaxy's Edge lightsaber blades are common anodes. So we're going to focus on this. Common anode, what does that mean? It means electricity comes in through this anode line, up and into all three of these LEDs. To pick your different colors, you can connect the cathode of the red, green, and blue to ground, or disconnect it to create the 3 different colors. So if you connect the cathode for red, cathode for green, and cathode for blue to ground, all electricity can flow through all 3 of those LEDs. The LEDs all turn on and they create a white color like you see here. Turn on one but not the others, you'll get an all red and all green and all blue again, just like I was showing you before. There are common cathodes, same idea, except power goes in through the anode of the red, the anode of the green, and anode of the blue, and then they all come out through the common cathode. These are not used in the lightsaber blade, so if you ever need to buy replacement LEDs for your Galaxy's Edge blade, or you want to make your own maybe, you want to go for common anode LEDs. They're not as easy to find as common cathode, but they're out there. Just be aware there are two types. And I point that out because here on this breadboard I have these three RGB LEDs here, or these three red, green, and blue single color LEDs here, but these two RGB LEDs, one is common anode and one is common cathode, and they look the same, they perform the same. If I turn this side on all the way, you can see, if I can get the switch to stay, all white, they look the same. There is no difference between how they look. Well, if you turn the right one off, they all perform the same. It's just a matter of how the electronics to the lights, to the LEDs, get wired up. Initially, when I started buying some LEDs to potentially replace the RGB LEDs in a holocron, which use the same as the RGB LEDs in the blade here, I bought these. These are common cathode, and these don't work. You need common anode. How can you tell it's common anode? Looking at the breadboard here, here's the positive line on this side, here's the negative side. Down here, you can see there is one wire from this RGB LED, the common anode, going into this LED. Electricity is then coming out through the cathodes of these three pins here, the cathode of the red, the cathode of the green, cathode of the blue. And as I make that connection by enabling it, by turning the switch on, the electricity continues through the resistor to ground. Common anode. This is common cathode. Again, the negative is the single, the common pin, connects to ground. That's called the cathode pin. Power comes in through these three resistors, through the switch to the to the anodes of the red, green, and blue pins there. So hopefully that makes a little bit of sense of what's going on with RGB LEDs. Common anode is what we have in the blade. Common cathode we do not have in the blade. They can be used, but not for the blade. They can be used for other things. This is a diagram of how the blade is broken down. And it's going to be a little bit long, so stick with me here. You have 4 banks of LEDs. That is why when it turns on and off, you'll see that it turns off or turns on in 4 sections. When it turns on, this section turns on first, then this, then this, then this. 4 different sections. When you turn it off, the same thing. This turns off first, and then this section all the way down. So you have 4 sections. These are all common anode LEDs. Each bank has one anode connection, essentially. All the anodes in this bank are connected together, and they get plugged into the microcontroller. Same here, here, and here. So the microcontroller can turn any or all of these banks on when it wants, and power will be going into all of those LEDs in each bank. What color they'll be depends on the cathode side, what's connected through the microcontroller to ground. So if, for example, the microcontroller connected the blue line to ground, left the green and red lines disconnected, and you had power to all 4 of these anodes coming through, you would get a blue color blade. If you have a blue color blade and you're turning it off, you would have power going through all 4 of these common anode pins into each bank, flowing through only the blue wire down to ground, and then the first bank will turn off. So that means that the microcontroller stops sending power to bank 1. And then the second bank turns off, so now I have 2 banks off. The microcontroller has just shut off power to line 2. And then line 3 gets turned off, so I only have 1 bank left turned on. And then eventually the microcontroller turns power off to that bank, and you have a blade that's been turned off. So hopefully RGB, you get the idea. Power comes from the microcontroller into your lightsaber blade. And I'm simplifying here. If anybody's a stickler for electronics, there's transistors and other things in here, resistors that help manage current, and because a microcontroller can't spit out the 250 milliamps or so of power, it needs to come elsewhere. I'm simplifying this a little bit just so you understand the basics. Don't worry about the details. They're not important right now. Also, again, this is all just the blade. In the blade, there's a microcontroller that has power and ground from the battery, and there's a data pin. So when you put your crystal in here and you turn it on, the microcontroller in the hilt tells the microcontroller in the blade through this data line, this is the color, start turning on. This is the color, start turning off, or the register a clash where, you know, it's like your lightsaber hits another lightsaber and it flashes for a second. All of that stuff is being commanded by the hilt here into the microcontroller of the blade. Does that make sense? Hopefully it does. Now, let's start looking at the blade itself. I'm going to take the blade apart so we can look at what's inside. There are 3 screws here, and again, at this point, don't do this unless you are willing to accept the fact that you are going to break your lightsaber blade. If you are worried about breaking your lightsaber blade, do not do this. So we'll just take these 3 screws out here. Standard Phillips, I don't know what size off the top of my head. I just grabbed the biggest bit in this little tiny screwdriver here, and that works. And with a little bit of sturdiness, just stick your fingernail in the seams here, and you can lift the halves apart. Be aware that these silver pieces that go into the grooves and help lock the blade into place are loose. So pull that top one off and keep it where it came from. The bottom should fall out and be there. So now we can start to see the blade. We can start pulling this out further. We can start to see the RGB LEDs. But I'll go just a little bit further and take this other cover off. And here you can see all the electronics that go into driving the blade. There, that black blob of epoxy underneath it is the microcontroller that's driving the blade. You can see the red and black wires there for positive and negative coming from the battery. The white wire, that is the data line that I showed in the drawing. Power comes in. We have, if you look here, 4 transistors here, 3 transistors here. Each transistor is driving 1 bank of the LEDs. And these 3 transistors, those are controlling the red, green, and blue lines for the whole blade. So now I'm going to bring this out more, and you can see the LEDs themselves. Just 4 pins. You can see these little tiny black rectangles, 3 with each LED. Those are resistors to limit the current going into the red, green, and blue pins, or coming out of the red, green, and blue pins. They are similar to these resistors that I have in each of these 3 test setups here to just limit the current a little bit. This is the blade essentially. I'm not going to pull it all the way out yet, just to give you an idea. The back side of it, there's nothing exciting. So the question now becomes, oh, there's one thing I want to show real quick. One demonstration I forgot. There is a problem that you will sometimes find where your blade is not producing the color you expect it to produce. And it's not a bad LED, it's your batteries, and I'm going to show you why. So I have individual red, green, and blue LEDs here, and these RGB LEDs. Right now I have 3 volts going into this breadboard. The battery pack will send, what, 3.5 volts or 4.5 volts up to the blade. No, actually there's a voltage regulator, so it's sending 3 volts, 3.3 volts to the LEDs. I'm going to start turning down the voltage. I have it connected to my bench power supply here. I'm going to start turning down the voltage, and I want you to see, this is going to simulate what happens as the batteries drain. Their voltage goes down. So we're going to go down about 2.5 volts there, and about 2 volts there, and you notice something has happened. This is suddenly orange. The blue is out completely. The red is the green is kind of dim. What's happening is, where is my piece of scrap cardboard? When you have electricity going through an LED, there is a minimum amount of electricity that is required for the light to turn on. The voltage difference between the positive side and the negative side needs to be above some certain minimum. That minimum is sometimes called the forward voltage, the voltage that it takes to turn the LED on. And different colors of LED will have different forward voltages. A blue LED is usually, I'll mark this up here, usually 2.5 to 3 volts to turn a blue LED on. Green can be anywhere from about 1.8 to about 2.2-ish volts. Red is typically around 1.5 to 1.8 volts. So I'm at 2 volts right now. You can see the green is barely on, but it is on just barely. And so you get a reddish orange color because, again, I'm at 2 volts now. That's well above what it takes to turn a red LED on. So this is why if your batteries are low, you're going to see colors other than what you expect. All you have to do is put in new batteries, and the voltage goes right back up to what it needs to be, and you'll get your whites and your blues, they'll come back. Okay. End of why your batteries need to be replaced. Back to this. I want to replace one of these because this particular style of LED is not something I have been able to find for sale anywhere. I have this style of LED where the pins match what's on here. So it's a red, common anode, green and blue, I believe is what it is. And so what I was thinking of doing, and this might be a really dumb idea, but I am thinking about removing one of these LEDs from the blade and putting this in its place just to see if I would notice the difference. Because part of the problem is these LEDs might be a little bit brighter than this LED, or they might be a little bit dimmer. So if I replace it with one of these generic RGB LEDs that I can find online for pennies a piece, it might be noticeable, or it might not. We're going to find out right now. So I am going to go away for a minute and attempt to do that. Yep. One moment. Alright, I'll share with you this little experiment to see if I can actually do this. I'm going to try and desolder one of these. I have a silicone mat underneath here that's going to be comfortable with the higher temperatures of the soldering iron. I am going to need flux just to help the solder flow a little bit better. This is a flux pen. We'll just go with, how about you? No, let's go with this one. This one's at just a slightly better angle. I should probably flux both just in case I forget which one I'm looking at. Now, what I'm going to do is I'm going to flood all 4 pins with the solder. Like so. And I then need some tweezers. I'm going to attempt to grab on from above here, reheat the solder, and lift them up. That worked very easily. Next I need to get to this drawer and find the magic that is, what is this? Solder wick or solder wick. Ah, they don't even have an L in this one. Excellent. They come from a country that doesn't respect the letter L too. I am going to reflux this. Flux really helps solder to flow. It is going to make your life so much easier if you're ever doing stuff like this. And I'm just going to press down and let the solder gets sucked up into the wick like it's a sponge. Okay. Next step is to remove all of that gunky looking brown junk. That is the flux from the solder. This is a cotton swab with 91% isopropyl alcohol. I'm just going to let it soak the area up as it starts to break down the flux, and the cotton swab will just absorb the liquid. And that looks good enough. Okay. And because it's isopropyl alcohol, it will evaporate as I am talking, and I don't have to worry about drying anything. So, the next step is to confirm the pinout, or the orientation here. You can see that one pin is longer than the others. The long pin is going to be your common anode pin. And I need to figure out, should I be putting it like that or like that? Which way? My guess is that we have two resistors on one side and one on the bottom side. I'm guessing that will line up with the pins here. So I'm guessing it'll go like that, but we need to confirm that real quick. And I'll do that by bringing in a multimeter here. I'm going to put it to diode mode. And I'm going to put the positive lead on what I think is the common anode. And in theory, that should be lighting up. Yep, I see that. That is just barely lighting up blue. You see blue, green, and red. So I am correct. Blue, green, and red. Let us make sure that this has a similar reaction. So if I put this, I'm going to bend this out of the way like so. Blue, green, red. Excellent. So that is perfect. Pin compatible. So now what? Now I need to trim these pins. So the LED is going to be about like that. So you can see that the LEDs have like a fat section in the lead there. I want to cut just above that. And before I do, can I get a sense of orientation? With the pins going this way, I have no chance. I have no chance. So I'm going to mark it instead. I am going to... Is that gonna turn blue? Yes. Okay. So that pin needs to be facing towards me, or down as you're looking at the screen. Otherwise, I'll have it in the wrong orientation. So I'm going to cut this about there. Okay. Now what? That is a fine question. This is the part where I have no idea how I'm going to do this. I'm making this part up now as I go along. First thing I think I want to do is I want to tin the bottom of these pins. So I'm just going to come in here, a little solder, and just try and coat the pins with it a little bit. Don't bridge. It's going to bridge. Not to worry. You can't see that. That is incredibly unhelpful. Come in here and maybe flux will fix it. If not, that's okay, because to be honest, I expect these pins to bridge out initially when I put this on the board. Okay. make sure that that blue is still there, and it is. Will it affect the ability for solder to take on that pin? You know what? I don't know. I don't think so. We're going to find out together. A little flux there. And I'm going to focus. Maybe I need to turn the light down a little bit. That's not going to help at all. Apologies, I'm more interested in getting this right than making this video viewable. So I'm just going to put some solder on those pads. That looks like a good amount. Grab my tweezers. Make sure this is oriented correctly. Well, this is going to be fun. Oh yeah, this is going to be real fun. Whose idea was this? Now there is absolutely no way that's worked. Oh, look at all the little solder balls underneath. Great. Just want to get rid of them because I don't need those screwing things up later. Okay, so I don't think that's worked quite right. Wow, now that it's in, it does not want to come out. That's almost connected. Almost. More flux. Because I don't want to add more solder. There's already plenty of solder there. I'm just going to keep reflowing until this thing sits right. There's no comfortable way to get in here. No, that hasn't worked at all. What a pain. Okay, one moment. I need to collect myself. All right, new plan. I cut all but the common anode LED lead, or pin, lead, wire, whatever, and bent it up so I can hold it in place with this helping hands. And I've placed it just so, and I think my plan here is to actually just go one pin at a time. I do not expect this to work, but let's find out. It looks like it's got a connection there. So now it's just a matter of doing the others. Yeah, this light, this background, this is not good for this camera. Anyways, that's, I think, the idea here. Just trying to secure the pins one at a time. I'll come back and show you if it works. Right, let's not mince words here. That sucked. And I hope this doesn't stand out, because if it does and I have to put the original back, I'm going to be unhappy. So the secret, I think, actually, let me go find myself another one to show you. So the secret, I think, is to do this. The long pin is the common anode, okay? And we know, don't clip the other wires where you need to, but leave the common anode, or common anode alone. And now remember what position it's supposed to be in. The way I have the board set up, the one pin should be on the side with one resistor, the two pins should be on the side with two resistors. So it's going to lay flat like that, and then do this. And now you've got a little handle to put it down and solder one pin into place to hold it in place, and then hit the others. And if you flood the area or you get a bridge, use some solder wick to get the bridge and try again. Use lots of flux, and once you have more than one pin down, when you go to, say, collect some solder from a bridge, only do it on one side. Make sure you have a pin that is soldered, that's anchoring the LED in place, that you are not applying heat to, so it doesn't fall off or lose its orientation. That seems to work, which is why I'm worried about this, because clearly if I have to put this back, I don't have a handle. I don't know what I'm going to do. I might just solder a handle on. I could do that maybe. Oh boy. Alright, so now I'm going to put this back together, and then you'll have to, well, I'll have to take a look and see if we can spot the replacement LED. Okay, here we go. I have a blue crystal in here. I'm going to use a magnet to turn it on. You tell me if you can spot it. You might be thinking, oh, it looks like it's a little dark up there. Nope, the LED was not at the end. Nope, I can't tell either. Well, I know where it is. It's actually about right here. Now, on the camera, you're probably not getting as much contrast as I do with my eyes here. It's actually, if anything, maybe a little bit brighter here. But it looks fine. You might notice the banding. If you look at the banding is less noticeable in the spot where I replaced that LED. Alright, let's try other colors. Here we go, red. And I can definitely tell from the banding that something's a little bit different here. But it's not, I mean, the color is correct. The color match is fine. The banding just isn't quite the same. I don't know what's happening there. Maybe this is a little bit better. I tried changing the, yeah, I think you can just see this spot here. It just looks a little bit dimmer. You can see the banding effect, and you can see that the banding just looks a little bit different here, and that's where I replaced the LED. One more color. Green. And again, you can see that something funny is happening up here. Just a little bit off, but it's really barely noticeable. I know it's there, so I'm looking right at it. Alright, so here we are. Dark room, black background. You can see the whole blade. And you can maybe just barely notice where the bad LED is. I notice it because I know it's there. I think most people would not notice that. Alright, so final thoughts. Yeah, replacing the LEDs in your lightsaber blade from Galaxy's Edge is possible with the generic ones that you can buy off of eBay. Just got to make sure they're RGB LEDs that are common anode, and you should be fine. Slight difference in appearance. I think that's really down to the package. And when I mean what I mean by packages, you can see that this RGB LED is sort of cylindrical with a domed top to it. This one, which came from the blade, you see how it has a square base to it before it gets to the dome top? That's the package, the case, the clear plastic here, the diffused plastic. That's what I mean by package. I haven't found any place that sells these with the square base and the dome top, just these. And I think the difference in the package causes the minor difference in appearance when you replace one of these with one of these. But if you don't know it's there, I don't think you'll notice it. And for the person who wants to sit down and replace many of their LEDs with these, good luck, because that is going to require an incredible amount of patience. But at least you have options if this thing breaks and you can't return it. So there you go. RGB LEDs inside of the lightsaber blade.